Hello and welcome to Learners Academy. In today's chemistry lesson, we'll explore one of the most important foundational topics, atomic structure. This is not only essential for understanding future chemistry topics like bonding and chemical reactions, but it's also a favorite area in exams. So throughout this lesson, I'll give you tips on how to remember definitions, understand concepts clearly, and avoid common mistakes. Let's get started. Let's begin by answering, what is chemistry? In your syllabus, chemistry is defined as the study of matter, its composition, properties, structure, and how it changes during chemical reactions. Memory tip: use the acronym CPSE to remember composition, properties, structure, and changes through reactions. So if someone asks you, what is chemistry? Just remember CPSC. Chemistry studies what stuff is made of, how it behaves, how it's built, and how it changes. Now, let's define matter. Matter is anything that has mass and occupies space. Yes, your chair, your juice, even the air in your room. They are all examples of matter. A common confusion is with gases. Students often think gases aren't matter because we can't see them. But gases do have mass. That's why balloons rise or fall depending on the gas inside. And they take up space. That's why a room can fill with the smell of perfume. So yes, gases are matter. Exam tip: don't just memorize. Ask yourself, does it have mass? Does it take up space? If yes, it's matter. Now comes the real question. What is matter made of? The answer is, matter is made of tiny building blocks called atoms. But what exactly is an atom? Be careful here. Many students say, an atom is the smallest particle. That's not completely correct. While it's very small, the correct definition is, an atom is the smallest particle of matter that can exist independently and has its own identity. Let's break that down. Imagine a mosquito. It lives independently and has its own identity. A grain of sand also exists by itself and has an identity. It's clearly sand, not water or dust. But are these atoms? No, because they are made of even smaller particles, which can exist independently and have its own identity. So if we keep going smaller, beyond sand, beyond bacteria, beyond molecules, we finally reach atoms, which are the first particles that can exist on their own and still remain what they are. Memorization strategy. Repeat this line aloud. Independent and has identity. That's what makes an atom. Also, in some past papers, the definition of atom was asked differently. The smallest neutral particle that can exist or take part in a chemical reaction. Both definitions are correct for exams, so write and revise both. Keep one as your main definition and the second as a backup. Now that we know atoms make up matter, let's go inside the atom. This is where atomic structure begins. An atom has two main regions. The nucleus. This is the center of the atom, and the shells which surround the nucleus. Inside the nucleus, we find protons, which are positively charged particles, and neutrons, which has no charge, or in other words, it's neutrally charged. Together, these protons and neutrons are called nucleons. Around the nucleus, in fixed circular paths called shells, we find electrons, which are negatively charged. Shells are also called orbits, orbitals, and energy levels. Exam tip: these terms are used interchangeably, so don't get confused if a question says electrons are in orbitals or energy levels. They all refer to the same idea. You can imagine an atom like a mini solar system. The nucleus is the sun in the center, and The electrons are planets orbiting around in different levels. Now let's study the 3 subatomic particles more carefully. Because this part is frequently tested in exams as a theory question, you should remember it. We will study 3 characteristics of subatomic particles: relative charge, relative mass and its symbol. Electrons have -1 charge, while proton has +1 charge. The number 1 shows that both particles have equal strength, but the difference of sign shows that both are oppositely charged. Neutron, on the other hand, is neutrally charged, or it has 0 charge. The relative mass of neutron and proton is 1, while that of electron is 1 by 1840, or in some places it is rounded off as 1 by 2000. This means that neutron has the same weight as a proton, while electron is 1840 times lighter than proton or neutron. The symbol of electron is the letter E, while neutron is denoted by the letter N and proton by P. For exams, remember, all symbols are denoted in small letters, that is E, P, and N, and should not be written in capital letters. Secondly, either 1 by 1840 or 1 by 2000 is acceptable for electrons' mass. Write this table on flashcards or sticky notes and revise it regularly. It appears as a theory question every 3 to 4 years. Here's something to think about. Since electrons are negative and protons are positive, they attract each other. This attraction is called the electrostatic force of attraction, and it's what keeps the electrons revolving around the nucleus instead of flying away. Just like the sun attracts the planets and makes them revolve around it, protons and electrons are always pulling on one another. This electrostatic force keeps the atom stable. Inside the nucleus, the total of protons and neutrons is called the nucleon number. It's also called atomic mass or mass number. So nucleon number equals protons plus neutrons. Let's take an example. If an atom has 6 protons and 6 neutrons, its mass number is 12. Memory tip: think of P plus N equals mass number. Let's quickly revise what we have covered, and you should remember, chemistry is the study of matter. It's about the CPSC of matter: composition, properties, structure, changes. Matter is anything having mass and volume. Atom is the smallest particle of matter that can exist independently and has its own identity. Atom has nucleus with protons having positive charge and neutrons with no charge. While outside the nucleus, electrons with negative charge revolves in shells around the nucleus. We also studied the subatomic particle symbols and its properties. We learned that nucleon number equals protons plus neutrons, which is also called as mass number. And electrostatic force keeps electrons attracted to the nucleus to keep the atom in stable condition. Okay, that brings us to the end of today's lesson on atomic structure. Remember, chemistry builds from this point. If you understand the atom well, you'll have an easier time with bonding, reactions, and equations later on. Final study tip: make flashcards for definitions and revise it. This small effort will pay off big in your exam. Thank you for watching. Share your questions in the comments below, and I'll see you in the next lesson.